Roll number 5. 6.
Present, sir.
7. Okay. 7. 8. 9. 10. 11.
Present, sir.
Okay. 12.
Present, sir.
Okay. 13.
Present, sir.
Okay. 14. 15. 16.
Present, sir.
Right. 17. 18. 19.
Present, sir.
Okay. 20.
Present, sir.
21. 22. 23. 24. 25. 26. 27. 28.
Present, sir.
Okay. 29. 30. 31. 32. 33. 34. 35. 36. Pratmesh. Joslino. Joslino.
Present, sir.
Soham. Okay. Soham. Atia. Atia. Anybody else is there?
Shweta.
1 minute, I'll just note down. Shweta. Then who else?
Deepa.
Deepa. Okay. Anybody else?
Hanmant Patel.
Hanmant. Okay. Then just go on telling your names. Hanmant, and then you can mute your video, Ilyas. Mute your video. Ilyas, I have noted down. You can mute your video. Video mute ಮಾಡ್ರಿ Ilyas. ಆ ವಿಡಿಯೋ ಐಕಾನ್ ಮೇಲೆ ಕ್ಲಿಕ್ ಮಾಡ್ರಿ ಇಲಿಯಾಸ್. ವಿಡಿಯೋ ಐಕಾನ್ ಇರ್ತೈತೆ ನೋಡ್ರಿ, ವಿಡಿಯೋ ಸಿಂಬಲ್, ಜಸ್ಟ್ ಕ್ಲಿಕ್ ಆನ್ ದಟ್. Right. Anybody else? Lateral entry students? Shweta, Deepa, Hanmant, Ilyas, then else? Who else?
Jocelyn.
Jocelyn I have marked. Anybody else? Anybody else? Lateral entry students? Okay. In the last class, I was discussing about the feedback amplifiers, right? Let me explain in brief about what are feedback amplifiers, what is their use, right? And which are the different types of feedback amplifiers. Okay. This is the basic block diagram of the feedback amplifier. Are you able to see the screen? Students, are you able to see the screen?
Yes, sir.
Okay. Now, this is the block diagram of the feedback amplifier. We know that amplifier is nothing but which amplifies the signal, Okay. Are you able to see the screen properly, students?
Yes, sir. We can see it properly, sir.
Okay, fine. See, now there is an amplifier in the forward path. This is called as forward path, right? And this amplifier amplifies the applied input signal. That is, the output amplitude is more than the input magnitude. Magnitude of the output is more than the magnitude of the input. That is what we call as the amplifier. Okay. Then the output of this amplifier is applied to another portion of the circuit which is called as the feedback circuit. This is called as feedback circuit. Now this feedback circuit, it takes the output of the amplifier and produces an output signal called as the feedback signal. It produces an output signal called as the feedback signal. This feedback signal is applied to a circuit called as mixer circuit. Is applied to a circuit called as mixer circuit. Now this is a mixer circuit. This is a mixer circuit. Mixer is a circuit which adds the applied input signal, that is input Vs signal, with the feedback signal. It mixes these two signals. It adds these two signals, and the addition of these two signals is applied as input signal to the amplifier again. Okay, so this is called as the feedback path or the feedback circuit or the feedback amplifier. Now, if the output feedback signal, if the feedback signal from the feedback circuit Vf, if it is in phase opposition with the input signal, then it is called as an amplifier circuit. If the feedback signal Vf, if it is in phase with the signal Vs, then it is called as the oscillator circuit. If the Vf signal is in phase opposition with the Vs signal, right, both are in opposition phase with respect to each other, then it is called as the circuit is called as the amplifier circuit. If the Vf signal is in phase with the Vs signal, both are in phase, right, then it is called as the oscillator circuit. Oscillator circuit. Okay. Now this is the basic block diagram of the feedback circuit. Okay. Hope you understood this basic block diagram. This basic block diagram is clear to lateral entry students. Block diagram is clear here. Yes, please. This basic block diagram is clear.
Yes, sir.
Okay, fine. So that's what it is. The mixer network combines the input signal Vs with the feedback signal Vf. The difference between these two signals Vs minus Vf is applied as input voltage to the amplifier. Okay. A portion of the amplifier output V0 is connected to the feedback network beta. Feedback network, what it does, it provides small portion of the output as feedback signal to the input mixer network. If the feedback signal and the input signal are in phase opposition with respect to each other, it is called as the negative feedback. Right? If the Vs signal and the Vf signal are in phase opposition with respect to each other, then it is called as the negative feedback amplifier. What are the advantages of the negative feedback amplifiers? There are few advantages of the negative feedback amplifiers. The advantages are, it results in high input impedance. The input resistance or the input impedance, right, of the circuit is high. Then output impedance is low. Output impedance will be low. Low output impedance. Better gain. The gain is good. That is the ratio of the output voltage to input voltage is high. Better stabilized voltage gain. Stable voltage gain. Low noise. The noise is less, right? Linear operation, the output voltage is varying linearly with respect to the input, that is linear operation. And good frequency response is the graph of the gain versus frequency, that is V0 by V in on y axis, and on x axis frequency. If you plot the graph, then that is called as the frequency response. So we get a good frequency response, good curve for the negative feedback amplifiers. So these are the advantages of the negative feedback amplifiers, that is high input impedance, better gain, improved frequency response, low output impedance, low noise, and linear operation. Okay. Now, which are the different types of feedback connections? There are basically four ways of connecting the feedback signal, right? That is, the different types of feedback connections are voltage series feedback, voltage shunt feedback, current series feedback, and current shunt feedback. What is meant by voltage feedback and what is meant by current feedback? The voltage feedback means whatever this output voltage is obtained from the amplifier, if the voltage is collected from that and applied as input to the feedback circuit, then it is called as voltage feedback. whatever the output from the amplifier is obtained, from that output, if we collect a portion of that output and apply as input to the feedback circuit, then that is called as the voltage feedback, right? If we are tapping off the current from the output of the amplifier and applying it as input to the feedback circuit, then that is called as the current feedback. There's a difference between voltage feedback and current feedback. If we are collecting the voltage from the output of amplifier and applying as input to the feedback, it is called as voltage feedback. If you are tapping the current from the output of the amplifier and applying as input to the feedback circuit, it is called as current feedback. Now, next is what is series feedback and what is shunt feedback. In the series feedback, the output of the feedback is in series with the input. The output of the feedback circuit, VF, it is in series with the input, then that is called as the series feedback. If the output VF, it is in shunt, in parallel with the input, then that is called as the shunt feedback or the parallel feedback. Okay, we'll see that what is meant by series feedback and shunt feedback. Now these are the different types of feedback amplifiers. The first one is the voltage series feedback. Voltage series feedback. You can see here, this is the forward path, that is the amplifier. Its gain is V0 by Vi. Here it is Vi. V0 is the output voltage. V0 by Vi gives the gain of the amplifier. It gives the gain of the amplifier A. Now, if this is the gain of the amplifier without feedback, that is V0 by Vn, it is called as open loop circuit. Open loop circuit, right? A is equal to V0 by Vi. If we want the gain of the amplifier with feedback, then A is equal to V0 by Vs. A is equal to V0 by Vs is the gain of the amplifier with feedback, because here for the Vs we are applying the feedback signal Vf. Okay, so AF is equal to V0 by Vs, that is gain with feedback, right? Then beta, it is the feedback factor, that is Vf by V0. Vf by V0. Vf is the output of the feedback and the input to the feedback is V0, that is output of the amplifier. That gain is given by, or the feedback factor beta is given by Vf by V0, output by input. So Vf will be equal to beta into V0. Vf will be equal to beta into V0. Okay. So as you can see here, the voltage is collected from the output and the output of the feedback is applied in series with the input. In series, this positive is connected to negative and negative is connected to positive, right, of the Vi. It is voltage series feedback. Next, voltage shunt feedback. In the voltage shunt feedback amplifier, the output is taken, that is the voltage output is taken from the output of the amplifier and applied as input to the feedback circuit, right? That is voltage feedback. Then shunt feedback means the output of the feedback, it is connected in parallel or in shunt with the input current source. The output of the feedback, it is applied in parallel or in shunt with the current source, right? Therefore the output of the feedback circuit is also the current. A is equal to, output is V0, input is II, the current II, input current. V0 by II, that gives the gain of the amplifier, output by input. This is the gain without feedback. If you want the gain of the amplifier with feedback, then it is V0 by Is. V0 is the total output, then exact input is Is. F is equal to V0 by Is, that is the gain of the amplifier with feedback. Then beta is equal to, output is IF, that is the output of the feedback. Then input of the feedback, input to the feedback is V0. So beta is equal to IF by V0. Beta is equal to, output is IF, input is V0. Beta is equal to IF by V0. It is the feedback factor. Okay. This is voltage shunt feedback. Output is the voltage which is applied as input to the feedback, and the output of the feedback, it is in shunt or in parallel with the input current source. This is called as voltage shunt feedback. Then current series feedback. In the current series feedback, here the output current is tapped from the output and it is applied as input to the feedback. The output current is tapped from the output, it is applied as input to the feedback, then the output is in series. Output of the feedback is in series with the input. Positive to negative, negative to positive. This is called as current series feedback. In the current series feedback, the gain of the amplifier is A is equal to I naught upon Vi. This is gain without feedback. I naught is the output, then input is Vi. I naught by Vi is the gain without feedback. With feedback, it is output is I naught, then input exact input is Vs. Therefore, I naught by Vs gives the gain of the amplifier with feedback. Now, beta is the feedback factor. Its output is Vf, that is the voltage. Then the input is the current I naught. Vf by I naught is the feedback factor beta, or Vf is equal to beta into I naught. Vf is equal to beta into I naught. Okay, so this is the current series feedback. The voltage shunt feedback. Just a minute. The voltage shunt feedback, in the voltage shunt feedback, the amplifier, it is also called as trans resistance amplifier, because A is equal to V naught by I. It is the ratio of the voltage to current, it is the resistance, right? It is called as trans resistance amplifier. This amplifier is also called as trans resistance amplifier because it's a ratio of voltage to current, Ohm's law. V by I is equal to R. Okay, and in the current series feedback amplifier, the ratio of I by V, it is conductance. The reciprocal of resistance is conductance. Therefore, this amplifier is also called as transconductance amplifier. Okay, transconductance amplifier. This A portion, amplifier portion, is transconductance amplifier. And the last one is the current shunt feedback. In the current shunt feedback, the output is the current which is tapped off from the output, applied as input to the feedback circuit. Okay, then the output of the feedback circuit, it is applied in shunt or in parallel with the current source. Output of the feedback circuit is applied in parallel or in shunt with the input current source Is. This is current shunt feedback. The current shunt feedback, output is I naught, input is Ii. A is equal to I naught by Ii is the gain of the amplifier without feedback. Then with feedback, A is equal to I naught by Is. Output is I naught, then input is Is. So I naught by Is is the gain of the amplifier with feedback. Okay, then feedback factor beta, it is output is If, right? Output is If, input is I naught. Therefore, beta is equal to If by I naught is the gain of the feedback circuit, or it is also called as feedback factor. Okay, If is equal to beta into I naught. Now, if you look into this, Is is getting split into If and Ii. Is is getting split into If and Ii. So this beta is getting affected by this I naught. As I naught changes, the beta also changes. Now, whatever current is coming here due to this Ii, right, and the current due to this If, that is this here. So both are affecting the output. Both are affecting the output. The current which is flowing I naught due to Ii, and the current which is coming here due to this current If, right? Both are affecting the output. The output current through the load resistance. This is current shunt feedback amplifier. Okay. Now in the series feedback connection, if it is a series feedback connection, it increases the input resistance. Yes, please.
Sir, admit Sanket.
Okay. Ask him to join quickly. So try to join on time. Okay. Please try to join on time. So series feedback, it is the connection is series feedback. It increases the input resistance, and the shunt feedback, it decreases the input resistance. The voltage feedback decreases the output impedance, and the current feedback, it increases the output impedance. Okay. Series feedback increases the input resistance. Shunt feedback, it decreases the input resistance. Voltage feedback decreases the output impedance, whereas the current feedback, it increases the output impedance. Now this is the voltage series feedback amplifier. We derived the gain of this voltage series feedback amplifier with feedback. This is a basic circuit. Okay. Then the gain of the amplifier that we found out was the simple derivation. AF is equal to A divided by 1 plus A beta. AF is equal to A divided by 1 plus A beta. That is the gain of the amplifier with feedback. It is the gain of the amplifier without feedback divided by 1 plus A beta. 1 plus A beta. Okay. That means if the gain of the amplifier is, say, without feedback is, say, 10, then 10 divided by this, suppose if it is 1 plus A beta is 2, then AF will be 10 by 2, that is 5. That means the gain of the amplifier with feedback is less than the gain of the amplifier without feedback. Okay. Then we derived the input resistance of voltage series feedback amplifier. We derived the input resistance of voltage series feedback amplifier, right? And the derivation. So this is the main circuit itself. Just have rearranged the terms, rearrange the parameters here. Okay. So if it is the voltage source, then the resistance will come in series. If it's a current source, then the resistance will come in parallel. That you have to remember. Okay. If it is voltage source, the resistance will always be in series with the voltage source. And if it is a current source, then that comes in parallel with the current source. Then the derivation for the input resistance with feedback, it is Ri into 1 plus A beta. That is resistance of the voltage series feedback amplifier input resistance with feedback, it is the input resistance without feedback into 1 plus A beta, into 1 plus A beta. Okay. So this is the resistance of the input resistance of the voltage series feedback amplifier. That is RIF is given by Ri into 1 plus A beta. Then we derived the output resistance of voltage series feedback amplifier. Output resistance of voltage series feedback amplifier. So there is one point regarding how to find the output resistance of voltage series feedback amplifier. Whenever we want to find the output resistance of voltage series feedback amplifier, then we have to short the input voltage. We have to short the Vs, right? And then we have to connect the voltage supply across the output terminals. Okay. This is a procedure for finding the output resistance of the any amplifier. If you want to find the output resistance or output impedance, we have to short the Vs input voltage and we have to connect the voltage across the output terminals. Okay. Then the current flowing due to this voltage V which we are connecting across the output terminals is I. So based on this, we are finding the output resistance of the voltage series feedback amplifier, and it is given by the equation ROF is equal to R naught divided by 1 plus A beta. That is output resistance of voltage series feedback amplifier is given by output resistance without feedback divided by 1 plus A beta. Okay. ROF is equal to R naught divided by 1 plus A beta. Then we also derived the gain equation of the voltage shunt feedback amplifier, gain equation or transfer gain of voltage shunt feedback amplifier. So the transfer gain or the gain of voltage shunt feedback amplifier with feedback, it is given by A divided by 1 plus A beta. Both for voltage series feedback amplifier and voltage shunt feedback amplifier, the gain equation is given by A divided by 1 plus A beta. A divided by 1 plus A beta. Both for voltage series and voltage shunt feedback amplifier, the gain equation AF is given by A divided by 1 plus A beta. Okay. Then the input impedance of the voltage shunt feedback amplifier is given by ZIF is equal to ZI divided by 1 plus beta A or 1 plus A beta. Input impedance with feedback is given by ZI divided by 1 plus A beta. Okay. For the voltage shunt feedback amplifier, this is the input impedance. Then we have solved examples that we have seen in the previous class. Current series feedback amplifier. For the current series feedback amplifier, the output impedance is given by Z0 into 1 plus beta A or Z0 into 1 plus A beta. Okay. Then these examples we discussed in the previous class. We have discussed these examples. Okay. Next, let us derive the gain with negative feedback for voltage amplifier. This is all the fundamental which is required, right? then we are deriving the gain with negative feedback for voltage amplifier. In the examination, they are asking these derivations, right? Derive the equation for gain of the negative feedback voltage amplifier. Derive the equation of the gain of negative feedback voltage amplifier. Let A be the gain of the amplifier without feedback. Okay, A be the gain of the amplifier without feedback. AF be the gain of the amplifier with feedback. AF be the gain of the amplifier with feedback. Then we know that A is equal to X naught upon Xi. What is the gain of the amplifier without feedback? Is X naught divided by Xi. X naught is the output of the amplifier and Xi is the input of the amplifier. So it is X naught by Xi. Just now we discussed. So AF, what is AF? It is the gain with feedback. If you want the gain with feedback, then what we are doing here, X naught is the actual output, actual input is XS, or say Vs here, Vs you can take, or Xs. So AF is equal to X naught divided by Xs. It is the gain with feedback. Okay, X naught is the output voltage, Xi is input voltage, and Xs is the source voltage. Okay, just now we discussed the block diagram, right? This block diagram. So this is the block diagram. Okay, so the output here it is X naught divided by Xi, that is gain without feedback. Then X naught divided by Xs or V naught divided by Vs is the gain with feedback. Okay. As it is negative feedback, the relation between Xi and Xs. What is the relation between Xi and Xs? Xs, right? Xs plus Xf, that gives Xi. Correct. Mixer circuit will add the source signal Xs with the feedback signal Ff. Correct. But here, as it is a negative feedback, Xf is minus Xf. As it is negative feedback, it is minus Xf. We discussed just now that it is negative feedback for the amplifiers. Correct. So Xi, it is given by Xs plus minus Xf. Xi is equal to Xs plus minus Xf. Just now I showed you the block diagram, basic block diagram of the negative feedback voltage amplifiers. It is Xi is equal to Xs plus minus Xf. Okay. This Xf is minus there because it is a phase opposite with respect to Xs. Therefore, it is minus Xf. So these two are added in the mixer network. Xs plus minus Xf, that is equal to Xi, where Xf is the feedback voltage. Xf is feedback voltage. Now gain of the amplifier with feedback, it is X naught by Xs. X naught by Xs. That is X naught divided by, what is Xs, students? Xs is equal to Xi plus Xf. This X minus Xf, it comes to the LHS, it will become plus Xf. So Xi plus Xf is equal to Xs. Xi input plus Xf feedback signal, that is equal to supply signal Xs. Write it. Xs is Xi plus Xf. Okay. Let us divide numerator and denominator by Xi. Let us divide numerator and denominator by Xi. If we divide numerator and denominator by Xi, then we get AF is equal to X naught divided by Xi, X naught divided by Xi divided by Xi plus Xf divided by Xi. Divide both numerator and denominator by Xi, we get AF is equal to X naught by Xi, that divided by Xi plus Xf divided by Xi. Okay. So X naught divided by Xi, that is equal to A. See here, X naught by Xi is the gain without feedback, that is A. It is A, that divided by Xi by Xi. Xi plus Xf by Xi can be written as Xi by Xi plus Xf by Xi. Correct. A plus B by C. How you can write it? A by C plus B by C. Yes or no? Xi by Xi plus Xf by Xi. That Xi by Xi will be 1 plus Xf by Xi, because A is equal to X naught by Xi. Okay. Now this is nothing but, I can write it as AF is equal to A divided by 1 plus Xf by X naught into X naught by Xi. AF is equal to A divided by 1 plus xf by x naught into x naught by xi. Actually, it is a divided by 1 plus xf by xi, but I will write it as a divided by 1 plus xf by x naught into x naught by xi. Is there any change in the equation? Yes, it is a divided by 1 plus xf by xi. If I write it as a divided by 1 plus xf by x naught into x naught by xi, is there any change in the equation? Does it affect the equation? Yes. Atia, does it affect the equation? Joslino, if I write like this, does it affect the equation? Joslino, Shweta, Shweta, is it affecting the equation here? Xf by x naught into x naught by xi, or is it remaining same? Deepa, Deepa, Prajwal, Mali, Prajwal, xf by x naught into x naught by xi, x naught and x naught will cancel, is it not? And it will remain a divided by 1 plus xf by xi. What is our main equation? A divided by 1 plus xf by xi. It is same. It is not affected, correct? I am writing it as xf by x naught into x naught by xi. X naught and x naught will cancel. It will remain as a divided by 1 plus xf by xi. Am I right? Therefore, AF will be equal to A divided by 1 plus, what is xf by x naught? What is xf by x naught? It is beta. Xf by x naught, right? Xf by x naught, if we just see the basic block diagram, if you look into the basic block diagram here, xf by x naught is beta. Xf is the output, x naught is the input. So xf divided by x naught or vf divided by v naught is beta, correct? This is beta. So here vs plus vf is vi, or vs minus vf. It is negative feedback. It will be vs minus vf is equal to vi. Okay, or vs is equal to vi plus vf, or xs is equal to xi plus xf. Are you getting the point here? Yes. Are you following here, students? Yes. Sampath Kumar,
Yes, sir.
Yes, sir.
following?
Yes, sir.
Okay,
Yes, sir.
Yes, sir.
fine, fine. So it is a divided by 1 plus xf by xi, that I can write it as a divided by 1 plus xf by x naught and x naught by xi. X naught and x naught will cancel. So it is af is equal to a divided by 1 plus xf by x naught is beta. Then x naught by xi. It is x naught by xi. Output by input is a. Gain without feedback. Therefore, af is equal to a divided by 1 plus beta a, where beta is the feedback factor. For the voltage amplifier, gain with negative feedback is given as AVF is equal to AV divided by 1 plus AV beta. For the voltage amplifier, gain with negative feedback, it is given as AVF is equal to AV divided by 1 plus AV beta, where AV is the open loop gain, that is gain without feedback, and beta is the feedback factor. Okay. So for any voltage feedback negative amplifiers, voltage negative feedback amplifiers, for any voltage negative feedback amplifiers, the gain with feedback is given by the gain without feedback divided by 1 plus the gain without feedback into beta. That is AVF gain with feedback for the voltage negative feedback amplifiers is equal to gain without feedback divided by 1 plus AV beta. That means what? This gain with feedback is less than the gain without feedback, because it is AV divided by 1 plus AV beta. Just now I gave the example of AV if it is 10, 1 plus AV beta if it is 2, 10 divided by 2 is 5. Therefore, AVF will be 5, AV will be 10. Yes or no? So, AVF gain with feedback is always less than the gain without feedback. Okay. So, this is the gain with negative feedback for voltage amplifiers. Okay. Did you follow this derivation, students? This derivation you understood? How to derive the gain with negative feedback for voltage amplifiers?
Yes, sir.
Okay, fine. Deepa, did you follow this? Deepa? Ilyas? Ilyas?
Yes, sir.
Yes, sir. Yes,
Followed this derivation, Ilyas?
yes, sir. Yes, sir.
Okay. Hanumant? Hanumant? Hanumant Patil? Ankita? Ankita?
Yes, sir.
Followed this derivation, Ankita?
Yes, sir.
Okay. Janvi? Janvi? Prajwal Gowda?
Yes, sir.
Understood this derivation? Prajwal Gowda?
Yes, sir.
Okay. Ramesh? Ramesh? Ratan? Ratan?
Yes,
Birje?
yes, yes, sir.
Is
Understood.
the derivation clear, Ratan?
Yes, sir. Clear, sir.
Okay. Okay. Fine. Rutvik? Rutvik? Sai Prakash?
Yes, sir.
This is clear, Sai Prakash derivation?
Yes, sir. Clear, sir.
Okay. Samir Ahmad?
Yes,
Fine.
sir.
Okay, fine. Sanket? Sanket?
Yes, sir.
Derivation is clear, Sanket?
Yes, sir.
Fine. Shubham? Shubham? Shubham?
Yes,
Any
sir.
difficulty in understanding Shubham?
No, sir.
Joslino? Joslino?
Yes, sir.
Understood the derivation, Joslino?
Yes, sir.
Okay. Atia? Atia? Okay. So students, in the next class, we'll start with the next topic, that is, we'll start with module for power amplifiers. Okay. That we'll take up in the next class. Okay. What is a power amplifier? What is the definition of power amplifier? Which are the different types of power amplifiers? Right? What classification of power amplifiers? What is meant by class A power amplifier, class B, class AB, class C power amplifiers? What is class D amplifier? All these details we'll take up in the next class. Okay. Thank you.